All right, guys. Good evening, everybody. How is everyone doing? Pleasant evening, everyone.
Good
Good
evening, sir.
evening. Night, sir.
All right. My
Good
apologies.
evening.
My apologies for being late. Just got a bit. The transportation got turned off in a different lane, so it's gonna take a longer time for me to get home. But I'm here. Better late than never, right? I'm about 3 minutes late. So, all right. Welcome back. If I sound too tired tonight, guys, because it's cause I am, but I'm gonna give you my 110 regardless. All right. All right. So a couple of things that I want to see before we start. One, you guys are going to get a test on January the 30th. No, January the 29th. All right. I have to give you one test. And I mean a test that is time constrained. So you guys have yet to receive any form of assessment. So I have to give you guys something. All right. So expect an assessment on January the 29th. I've used one of my class and try to see where you guys are at on that time constraint assessment. All right. I'm probably going to give you more than the hour and a half. Right. So it's probably going to be 2 hours. So you will have the time to go up until 9 o'clock. And then I'll give you 45 minutes to upload to Google Classroom so I can mark and get you back your results. All right, so just make a note of that you'll be getting an assessment on January the 29th. I will let you know what the topics are over the course of the weekend. Okay. All right. Secondly, I would love to at least go through the method of data collection because I see some person that are
Just a
sending.
minute, sir.
Yes, go ahead.
The 29th is on a Thursday.
Oh,
You'll have to
sorry.
be
So it's the
the
28th.
28th.
Yes, it's the 28th. Thank you. It's the 28th. All right. Now, secondly, I'd love for somebody to remind me on Wednesday that I need to at least give you a good run through of the collection because I could have sworn I went through it with you, but I just remember that I only went through the introduction. So there are some persons who are, sending me some stuff and it looks okay, but there are things in it that I need to make sure that you have in the method of data collection before I can approve it. So on Wednesday, I will be pulling up a screenshot of the method of data collection so I can kind of run through it with you so that you guys can get it sorted out properly. I promised Mr. Hanst and Miss Witter that I'm going to go through it tonight, but I couldn't find the document, so I'm going to go through it on Wednesday. All right. And that's it. That's the only announcement I have for you. We're just going to pick up from where we left off. Unfortunately, some of you guys were not able to join us on Sunday, but I just saw it go, we'll be back here again Sunday coming. So I know the routine, just reach out and you all can access the link and we can do some practicing. Sunday was okay. We did about 3 or 4 questions. So it was good. All right. All right. Let's get into it then. So tonight is Monday night and let's pull up that document then of what we did. Yeah. All right. Boiling down, ladies and gentlemen. We're boiling down. January is almost over. And by the blink, February done. Then we have March. Then we have April. And then, say it's that time of the year. So we have a lot of time, but we still don't have a lot of time. So let's make do with what we have, okay? All right. So while it's low, guys, we have an opportunity to learn, and every day presents an opportunity to improve at something that we did the last time, right? So based on this document that I'm looking at, it seems as if the last thing that we went through in algebra was.
Sir,
Yes, go ahead.
I'm not seeing your screen.
Oh, you're not? Okay, thank you. All right, so the last thing that we would have went through in our algebra class would have been algebraic fractions, right? So tonight I'm going to be a little bit cheeky. I'm going to teach more things than I would normally have to teach. So tonight we're going to go to a topic known as factorization, right? We're going to go to a topic called factorization. I'm going to try to teach, I'm going to try my very best to teach all four techniques, but I want to ensure that I teach at least 3 of them tonight. Okay, so we're going to go to factorization. All right, ladies and gentlemen. Give me a minute to push this page. It usually doesn't take this long, you know. When I try
Sir, I'm not seeing a screen nor hearing anything.
I think he jumped off. I think there's something wrong with his internet or something.
Okay, thank you.
Guys,
Yes, sir.
Yes, sir.
none of you guys were hearing me a while ago?
No,
No,
sir.
sir.
No,
No,
sir.
A joke on me. No, my heart. Oh God, no, wait. Where did I lose you guys?
Sir, from the beginning.
Jesus have mercy. Allah will not tell.
Aye.
Sir, we thought you dropped or your Wi-Fi was giving
Exactly,
trouble.
sir.
I
We're
cuss,
so confused.
guys, me cuss now all gonna cause me then I said to myself, say, do you understand? No one wants to answer me.
Okay.
Sir, we
Jesus
thought
have
you dropped
mercy.
from the
No. Allah will not tell. I'm not serious. So hold on, wait.
Yes, sir, because we thought that you had someone was suggesting that probably you have internet issues or
No,
so.
me there teach out my heart. Me there
Sir?
teach out my
No.
heart. Me there teach out my heart. Oh God. Seriously?
But sir, we didn't see you online or anything.
Sir, we didn't even see
We
your
didn't see
screen.
you.
So wait, no see the party part me say factorization. No see this?
No, sir.
Sir,
No,
we
sir.
didn't see anything. You were
Wait.
muted
just
or
about
No,
to
speaking
sir. We
freely.
only hear you
Hold on,
say
hold on.
factorization, and that's it. Kaka.
Oh, Coco.
him gone
No,
again.
so.
Oh,
No, me there, see me here, me there. Lord. So I got kicked out and I didn't know. Oh
Yes,
my
you did.
Yes,
Lord.
sir. Oh my God.
So don't see nothing in the yellow with me to explain or nothing like that.
No,
Nothing
sir.
whatsoever.
Nothing.
Nothing.
Blank. We were just here waiting for you to come back on.
Oh my God. All right, look at this. Oh dear. All right, you can take a picture, screenshot of that. I didn't really go much. I didn't really go far.
We're not seeing anything
I've
now,
seen your
sir.
screen.
It's unbelievable. But they teach up my heart and I want to vibe, you know. Oh gosh, Jai. The good thing about it is that the class is being recorded, so even if you can watch the part, they will see it. Oh Lord. All right. Anyways, yeah. So this yellow piece, can you see this here? Wait, it's loading. Come on, we know say the devil at play now. So all right, you can go ahead, guys, and can you see that? You can go ahead and take, guys.
Yes, sir.
Yes, sir.
Yes,
Yes, sir. We're
sir.
seeing it.
I can go ahead and take a picture, or you can write it off. It's gonna give you like a minute or so to screenshot it. So what I was explaining, or what I was apparently teaching myself, was that factorization is the method by which the highest common factor or term is used to divide another expression, and the remainder is written in a pair of parentheses. That's all I wrote on the screen. Then I begin to proceed to say that there are 4 factoring techniques. The first technique is the HCF method. The second method is the grouping method. The third method is the difference of 2 squares. And the fourth method is the quadratic. I didn't really say anything else after that. Right? I just went into started to talk about what the HCF is. You guys are here?
Yes, sir.
Yes, sir.
Right, please. No. Yeah, someone just go on to just say so we can listen to there. Oh my gosh. All right. So here we go. So what I was saying to you earlier, all right, let me just run back through it really quickly. We were saying that back in grade 2, grade 3, or grade 4, the teacher would have asked you what is the HCF of, say, 6. Teacher would have asked you what's the HCF of, say, 6, 9, and 12, right? Back in grade 2 and 3 and 4, you would have gotten a lot of exercises on this, whether we like it or not. And it is safe to say that most persons in here should know that the answer is equal to 3, because 3 is the highest number that is exactly divisible into all 3. 3 can go into 6, 3 can go into 9, and 3 can go into 12. There is no number that's bigger than 3 that can go into all three. There is a number that's bigger than 3 that can go into 6, which is 6. There's a number that's bigger than 3 that can go into 9, which is 9. And there's a number that's bigger than 9 that can go into 12, which is 12. But we need one single number that can go into all three. All right. Let's say then that I ask you for the HCF. Let's say then that I ask you for the HCF of 12, 18, and say 36. Now, when you look at this one, the HCF, by looking at it, you could probably guesstimate that the answer is 6, because 6 is the highest number that is exactly divisible into 12, into 18, and also into 36 at the same time. That's what we would have learned back in primary school. Now, when you get higher up in math, they're going to start asking you for stuff like, what is the HCF of, say, x squared, x3, and say x5. And say x5. Now, all of a sudden, it don't look like maths anymore, because for us mere mortals, mathematics is supposed to be numerical. Once you begin to throw letters in the equation or in the expression, then all of a sudden, it don't look like maths anymore. However, on the contrary, while some person will think that this is a very difficult process, it's actually way easier than what you think it is. Because to find the HCF of an expression that is algebraically written, the HCF is the term with the lowest power. That's the rule. So the HCF is the term with the lowest power. Ever there?
Yes, sir.
Right. So in this case, then, my HCF is going to be x squared. Why? Because x squared is exactly divisible into itself. X squared can go into x cubed because there's going to be an x remaining. And x2 is exactly divisible into x5 because when you divide x2 into x5, we're going to have 3 x's left. Let me demonstrate. x5 means x5 means x times x times x times x times x divided by x squared is x times x. So when we're dividing, we know say cancel, 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 cancel. So we know say 3x are left over. So we can confirm that x squared divides into itself, x squared can divide into 3, and x squared can divide into 5. And that's going to give us our highest common factor. All right? Now, there are going to be scenarios where you have to find the HCF. And unlike example number 1 and 2, where your HCF is just a numerical value, unlike example number 3, where your HCF is actually a letter, an algebraic written letter, your HCF can be a combination of both. So let's say then that I was to ask you to find the HCF of, say, 6x to the 4th, comma, 12x to the 5, comma, 9x squared. So not only are you required to find the HCF of the number, but you're also required to find the HCF of the letter and combine them. So to find the HCF of this expression, we want to write down what's the highest number that can go into 6, into 12, and into 9. And in that case, the HCF is going to be 3. And then we're going to attack the letters then now. What's the HCF of x4, x5, and x squared? So what we're looking for now is the expression with the lowest power, which in this case is going to be x squared. So therefore, we attach the x squared onto this, and then 3x squared becomes the expression that is the lowest. It's the highest expression that can divide into all three. All right? So that is how you find HCF. Everybody clear on that?
Yes, sir. Yes, sir.
Yes, sir.
All right. So now that we learned how to find the HCF now, we haven't learned how to factorize as yet. Now, in all 4 techniques that I've listed earlier, HCF method, grouping method, example, the difference of two squares, that's a different ball game, and the quadratic factoring, the HCF is a key component in all 3. So of the 4, 75% of your factoring techniques will require the HCF skill, the ability for you to find the HCF and then use the HCF to divide into the expression. Now, if everybody have that, right? If you have that, here's what we're looking at next now. What we're looking at next now is we're going to actually learn how to factor. Because what I've taught you thus far is I've only taught you how to extrapolate the HCF, how to find the HCF when it's numerical, how to find the HCF when it's algebraically written, and then I look at how to find the HCF when they're combined. What we're going to do now is we're going to find the HCF, and then we're going to use the HCF to divide into the expression. So let's say, for example, I wanted you to say factorize, right? So that's the word that we use, factorize. Factorize is a verb, by the way, okay? So it's an act of doing. You're doing something, right? So finding the HCF would be like the noun, right? But factorizing is the verb. So you're doing the action now. So you're asked to factorize. I'm going to start with something simple and I'm going to build it up. So let's say that you're asked to factorize this expression, 3 minus 12ab. All right? 3 minus 12ab. Yeah, and you're asked to factorize that. In the first example, you will see where when I'm factorizing, my factor is just a numerical value. Now you'll recognize here that there is no possible way for you to subtract 12ab from 3. Why? Because we are not allowed to subtract unlike terms. Hence the word factorize. Once you see the word factorize, no form of subtraction, addition, multiplication, or division can occur. That's why we replace the word simplify with factorize. Now, the question I'm going to ask you is, what number do you think is exactly divisible into 3 and into 12?
3.
3.
Good. I'm going to then take out the 3. If you then notice that the A is on one side, but it's not on the other. The B is on one side, but it's not on the other. So therefore, neither A or B is a common factor. I'm going to open the bracket. Now I'm going to use the 3 now, and I'm going to divide the 3 that I took out. That's the 3 in red. I'm going to use the 3 and I'm going to divide it into those two terms. How many times does 3 go into 3?
3.
Pardon me?
1, sir.
1 time. And how many times can 3 go into 12?
4.
And then I'm going to put back down the what? The A and the what? B. I'm going to close my bracket, and that's my answer.
Oh.
Yes, that's my answer. 3 open bracket, 1 minus 4ab. All right? That's an easy example. Let's look at number 2. In the second example, I'm going to show you one where you're seeing the number, but there is no common factor. For example, 5x squared minus 16xy. And again, the instruction is to factorize. Now pay attention to both 5 and 16. Do you notice that apart from the number 1, there is no number that is exactly divisible into 5 and 16? There is none. Because 5 is a prime number and 16 is an even number. So therefore, there is no number that is exactly divisible into 5 and into 16. So for this example, our highest common factor is not a numerical value. Our highest common factor is actually a letter that is repeating itself. What letter do you see right in this expression that is repeating itself?
X.
X. Now, remember earlier, we said that if we're going to take out a letter, we have to take out the one with the lowest power, not true? So which of those two x's are we going to take out? Are we going to take out the x squared or are we going to take out the x?
The X.
So you're going to take out the x right here. Open the bracket. Now, we're going to use this x now and divide it into the 5x squared. Now, the way how I word it may not sound like I'm dividing, guys, but I'm actually dividing, okay? So here's how I'm wording it. How many x's do you see here?
2,
And how many did you take out of it?
1,
So how many would be left in the bracket?
1.
Along with the what? Along with the 5. Because we didn't do anything to the 5. So when I took out the x from the x squared, I left one of the x on the inside along with the 5. And now tell me, if I remove the x from the 16xy, what do you think is left inside the bracket?
16y.
16y. Close the bracket, and that's my answer. So the expression has been factored. I've rewritten the expression into factored form, right? So I've placed them into 2 separate terms that when multiplied will produce back the original answer. All right, so that's example number 3, where your expression is a numerical value. Sorry, is an algebraic expression. Now, in example number 3, I'm going to show you where you can...
Someone is in the waiting room. She said she was using the wrong code.
All right. So for the third example then, right? For the third example, I'm going to show you where sometimes you have to take out more than one terms, right? In example number 1, we took out a number. In example number 2, we took out a letter. In example number 3, we're going to take out more than one terms, right? So here, look at this expression then. We end up with something like, say, 9, pardon me. So we take out this expression now. You're asked, same instruction up top, factorize. 9x, let's not use x, let's use a different letter. So 9 P5Q plus 5 P3Q7 or Q2. All right? And you're asked to factorize this, ladies and gentlemen. Now, when you hear the word factorize, please remember, guys, if them could have did, if you could have add the expression or subtract them wouldn't use the word factorize. They would have just use the word simplify, right? That have to make sense. If they wanted you to add them, if they wanted you to say 9 plus 5 is 14, and then do some other stuff with the P's and the Q's, they wouldn't use the word factorize, because the word factorize simply and indirectly suggests that addition and subtraction is not permitted. It's not permissible. It's not possible.
Yes,
so the word
sir.
yes, go ahead. Go ahead.
Question. The numbers are the powers?
The numbers into the 9 and the 5 you're talking?
No, the 5, the 3, and the 2.
Yeah, those are powers. Yeah.
All right, sir.
Those are powers. All right. So in this example then, right, if you look at the 9 and the 5, there is no number that is exactly divisible into 9 and into 5. So there is no common numerical value. But if you look carefully now, you'll realize that P is repeating itself, Q is repeating itself. Now be very careful, because you have P5 and P3. You have to either take out the P5 or take out the P3. How do we know which one to take out?
Sir, is it the one with the lowest one?
That is correct, the lowest power. Very good. So we take out the P3. And how do you know which one of the Q's to take out? Same answer. Take out the Q with the lowest power. This one is Q to the what? 1. So you just take out the Q right there. So open the bracket then. All right. Once you open the bracket, your job now is to write back what is left after you divide the expression. Now, if you notice I didn't touch the 9, so the 9 is going to come back in the bracket, right? How many P's was in the expression?
2.
No, man, look. Oh, sorry, 2 is left. What I wanted you to answer was, how many P's did we initially have? 5. And how many did we take out?
3.
3. So how much P's is left?
2.
Very good. Plus. Oh, hold on.
Q.
Right, no, the Q that was there, notice the Q that was here? We take it out, so it's outside. So nothing can left inside, because there was only one Q. So nothing can be left on the inside. Plus, notice we didn't do anything to the 5. Write it back, 5. How many P's was in the expression over here?
3.
And how many is on the outside? 3. So no P's is left on the inside. However, now look at the Q. How many Q's was on the inside in the expression?
2.
2. And how many is on the outside?
1.
So only 1 is left on the inside. You close the bracket, and that's the end of the factorization. So like I said to you before, when you hear me using the word take out, it's just a way of bringing the message across. But technically, you are dividing, right? You're dividing. All right? So that is basically the introduction of factorization by the HCF method. Now, I've shown you an example where you only take out a number. I show you an example where you take out only a letter. I show you an example where you take out more than 1 letters. Now I'm going to show you an example where you take out both a number and a letter. And all the factorization you're going to experience will require one of these 4.
What don't?
Pardon me?
Could you scroll back so I can take a picture, please? Because I don't like to write when you're teaching. I miss.
Okay, no problem.
Thank you.
All right. So here's an interesting example now. Rewrite my instruction. Factorize. So factorize 10. Oh, what is that? 10. Let me just erase this. Don't confuse somebody. 10 a squared b5 minus 5 a4 b3 plus 15. It's not 15, Mr. Peart. 15 a3 b2. And so you're asked to factorize this expression. Once again, ladies and gentlemen, I'm reiterating and I'm emphasizing on this word called factorization. If you're asked to factorize, there's no way in the world that your first step should be to try to take the 5 away from the 10 and then add it back to the 15 and get 20. Because factorization prevents you from doing that. The word factorize means you're going to take out a common factor. That means you want to take something out of all three that is art. You're gonna write down an expression that is exactly divisible into all three. Now, to do this, we're gonna attack them one at a time. We're gonna attack the numbers, then we attack the A's, then you attack the B's, and then when you finish attack all of them, you would have obtained your HCF. Let's attack. What's the highest number that is exactly divisible into 10, into 5, and into 15?
5.
5.
Correct. From the A's, we have A squared, we have A4, and we have A3. Which of the A's have the lowest power?
A square.
Very good. From the B's, we have B5, B3, and B2. Which of the B's have the lowest power?
B square.
So therefore, you've attacked the letters, and you have attacked the numbers, and you've written down 5a squared b squared. That means 5a squared b squared is your HCF. Now, you have just extrapolated 5a squared b squared from R3. That means 5a squared b squared is exactly divisible into all of those three terms that was previously written. So therefore, if you extrapolate that from each of those expressions, something must be left. We have to figure that out. Now, question. How many times? You attack it one at a time now. How many times does 5 go into 10?
2.
Very good. And how many A's was initially in the expression for the first one?
2.
And how many did you take out?
2.
So what's safe to say about how many A's is left inside?
2.
None.
None. So leave that alone. Move to the B now. How many B's was initially in the expression for the first one?
5.
How many did you put on the outside?
2.
So how many is left on the inside?
3.
Very good. We're going to move to this next expression. Now, how many times do you think 5 goes into 5?
1.
Right, but in algebra we know, so we don't write the number 1. You can write if you want to know, but we don't write it. So we just basically say 5 cancel 5. That's basically what we say. But we know it means 1. Now, how many A's was in the second expression?
4.
How many did you put on the outside?
2.
So how many is left on the inside?
2.
Very good. How many B's was in the second expression?
3.
And how many did you put on the outside?
2.
How much left on the inside?
1.
Move to the third expression. How many times can 5 go into 15?
3.
3.
How many A's was in the third expression?
3.
How many did you put on the outside?
2.
How many is left on the inside?
1.
How many B squares was in the third expression?
1.
In the third expression?
It was just 1b square.
No, man. No, the 2 means you have 2 B's. That's what the question is. How many B's was in the third expression?
2.
And how many did you put on the outside?
2.
So that's safe to say that none is left on the inside. You close the bracket and your expression has been factorized.
Sorry, you make maths look easy.
But it is. Every time you get a question like this is how it's approached. It's just the wording. It's just how the teachers them normally word it, right? Because we word it according to how the textbook do it. But if you do it like that, people won't understand. Now, once you start to do the expression like this, no matter what kind of expression they give you to factorize, as long as you have this approach towards it, then it's going to be this easy. All right?
Okay.
So here's what I'm going to drop now. I'm going to drop a little notepad right here now. And this notepad is going to tell you how do you identify the HCF method, because when you learn all 4 technique, is when you learn all 4, The problem is identifying which technique match which question. And it's upon me teaching this over the past 2 years that I started to do this. So what I do is that I give students a little note. How do you recognize the HCF method? The HCF method is easily identified when there is a common factor, meaning like a common number, a number that is exactly divisible, or a repetitive term, a repetitive term, meaning that you're seeing something repeating itself. So it's either when you look at it, you see something like one number where it can go in on one next number, or you see one letter where they're on the left and that same letter is on the right. And if you observe very carefully, put it right here, zoom it out right here. And if you observe carefully in all the examples that we have done, look at this example. You can look at the 10, the 5, and the 15, and you can see that 5 can go into R3. And you can look at the A and the A and the A and the B and the B and the B. You know, so there's something repeating. So you know, so it's the HCF method. And if you scroll up back, you look at all the other expressions. You look at example number 3, P and P, Q and Q. But with the 9 and the 5, you know, say the number no repeat. So therefore, no number no common. But as long as there is something that's repeating itself, then the method required to solve or to simplify or to factorize, as them say, is the HCF method. Okay? So that's the clue. Now, this is going to lead us now into the next technique now, which is going to require this skill set, right? But the next technique now is going to be called factorization by grouping. And it kind of self-explanatory when you check it out, you know. Hold on, let me just write this up. All right, so hold on. Let me just use the notepad instead. It's easier to type. So factorization by grouping. Let's type that in. So technique number 2, factoring by grouping. All right, so it kind of self-explanatory, right? Not trying to make anybody feel bad, right? But we don't learn how to factor. So the only thing that I've added on to this technique is grouping. And what grouping suggests is that you have to either group the terms by a numerical value, or you group the terms by a particular letter. Now, majority of the time, when the expressions are given to you, they are automatically grouped, meaning that they give you the expression in grouped form, but there are some cases where you have to regroup. Hopefully time allows and we get a chance to go through it. Do you mind if I go to 8:45? Do you mind
No,
if I
sir,
go?
go ahead.
Already lost some
You
time.
can continue.
Okay, I just want to know if I can go up to 8:45.
Sure.
Okay. All right. So factoring by grouping. Let me see if I can grab. Let me see if I can grab an example. Give me a sec, guys. Hold on. Where's my phone? I'm trying to grab an example. That's very so. All right. Let me write some notes for you here. So when factoring by grouping, right? We group our terms in pairs, either by a numerical factor or an algebraic variable. All right. Now go on with itself again, people. Hold on. In the meantime, while that is loading, I don't know what's happening to my device. What a load. All right, so hopefully don't delete everything that we've just done. Or deleted the last part. That's fine, that's okay. All right, so factoring by grouping. All right, so factorization by grouping. All right, so here's the notes. When factoring by grouping, we group our terms in pairs. Pairs meaning two, either by a common factor, which is numerical, or either by a numerical common factor or an algebraic letter. Algebraic variable, don't use the word letter, algebraic variable. Or both. Or both. All right? And then now, pretty much that's it. So let's look at an example now. Delete this. Move this here. All right. Let me just grab an example from off the internet. Give me a minute, guys. All right. All right, so trying to find some sensible examples, you know. Leave these ones sensible. Give me a second. They're a bit blurry. A second, guys. I'm trying to find some that's sensible. All right, let's. Give me a second. All right, let's try this one. All right, let's try this one. Maybe not my favorite, but let's try this one. All right, so the instruction will say, and I'm going to write the instruction, factorize. And here it is. It says 3r cubed minus r squared okay. Enter we and one nice little vibe, you know, the devil always play advocate, you know. See that? So there's a nice little vibe. And he decides I'm gonna make this thing start a problem. So not gonna frustrate me today. Not today, miss.
It's enough.
So stay, man. You know, we're not gonna make that bad of it. we're going to get through what we need to get through. Right? So when time learning take place, then you always have something will come intervene. That's why you never go on when time something is cut off. Right? You see, all of a sudden now everything is working. All right, so r squared. All right, so 3r cubed minus r squared plus 6r minus 2. All right, so look at this example. Perhaps not the best example that I would like, but it can work with. All right, now pay very close attention. Using the knowledge that we have garnered from the previous example, for something to be an HCF, there has to be something that is repeating throughout. Emphasis on the word throughout. Emphasis on the word throughout. So if you look at this, you can see r square, r, but the last one doesn't have an r. Therefore, r is not a common factor. If you pay attention to the numbers, you'll then realize that 3 can go into itself, 3 can go into 6, but 3 cannot go into 2. And if you look at the number 2, 2 can go into itself, 2 can go into 6, but it cannot go into 3. So when you look at this expression, there is not a single number or a single letter that can divide into the whole entire expression. So what this requires us to do now is to place these into what is called groups of 2. And so the factorization by grouping is the easiest one to identify. Why is it the easiest one? Because it's the only expression that has 4 terms. It's the only one that has 4 terms. So therefore then, we place them into groups of 2, like that. All right. Now, once you place them into groups of 2, ladies and gentlemen, once you place them into groups of 2, you can then factor the expression bracket by bracket. And after factoring them bracket by bracket, you're going to see something that happens. For the first expression, we're going to use the HCF method, because once you bracket them, you're segregating them. You're now saying the first 2 belong to each other and the last 2 belong to themselves. So you go factor them bracket by bracket. Now in the first bracket, we have 3r cubed minus r squared. What is it that's repeating itself? Which one of them? A 2r then, you have r3, you have r2, so you have to pick the right one.
R3.
Remember, so you have to choose the r square. You have to pick the one where have the lowest power. Use back what you learned a while ago. All right. Now, how many r's was initially in the first pair, in the first term?
3.
And how many did you put on the outside a while ago?
2.
So how many is left on the inside?
1.
Along with the what?
3.
Very good. So you have 3r. Now, how many for the second term now in the first bracket? How many r's was there? Sorry, by the way, how many times can r square go into r square? Didn't hear that?
1 time.
1 time. So you put the 1 there, close the bracket. Go to the second term now, right? Now in the second term, if you pay close attention, you realize that r is not repeating. But in a have to be 1 letter. It can be a number. Is there a particular number you think can go into 6 and 2?
2.
Very good. So we're going to pull out the 2. Open the bracket. 2 into 6.
3.
I leave back with the r, because we never touch the r for the second bracket. So you leave the r alone. And how many times can 2 go into 2?
1.
Now, what do you notice in that line number 2? Tell me what you notice in line number 2. What is so?
It's the same
what do
thing
you pick
on
up?
the first side.
Right. So the same thing that you have in the first bracket, you kind of end up with the same thing in the what? Second bracket. That is your clue. That is your clue to know that you're on the right track. So therefore, we're going to say that these two terms are what we call the common terms. So we're going to place those in a bracket by themselves. All right? Now I'm going to run one line through this, and I'm going to run one line through that. Why I run the line through it is not that I deleted it, you know. I run the line through it so that you can tell me what is left. What is it? What terms do you see that's left? And put them together in one bracket.
R squared plus 2.
R squared plus 2. And that is how you factorize that expression. Stacey, I'm so sorry. Did I not send you the right code?
Sir, you
Did
know,
I
I
not
got the
send?
code and I don't know what happened. I don't know what happened. But I was just using the old one and, you know, waiting for a very long time. I was on for about 10 minutes after 7, you know.
Yeah. I'm so sorry
Yeah.
about that.
I just will have to wait on this video and then you know, pick up from where.
Here's a fun fact. I was teaching myself while these students were stuck waiting on me to come.
That's also in the group.
Yeah, I was
I
stuck.
know.
So I was teaching myself something that I already know for decades. While these students are telling me they have no clue what I said. So tonight
Good
is
thing
one of
you're
those
learning as
nights.
part of your brain.
Tonight is one of those nights, man. One of those nights, you know?
Yeah,
Let's grab
And
another
I had
example
internet
now.
issue earlier too. So
Now,
all of that.
I say go, man. I say go.
So how
So I
early
hope
we
you're
can
catching
get the
on still.
video?
Come back down, please.
How early you want it?
Boy, if you could have
You want
posted
it tonight?
tonight would be better. Yeah, man.
I could download it and post it tonight. Or I
Uh-huh.
could but tonight I'm too late. My algorithm will run so late. I don't know. All right, I could
Sorry.
still post it.
Not too late, you know, because Melissa really, you know, set we back in a way. So anything for make up. Because right now, me talk to you, I'm on another meeting in another group
Okay.
at the same time. So I don't mind going through it.
All right then, no problem.
All right, thanks.
All right, so we're gonna try to do another example, right? We're gonna do another example. Let's try one with an X, right? Let's try one with an X. So, like kind of similar one. Me no wonder one day. Try. I need to get some sensible ones. Hold on. Let me
Hold on,
just.
please.
Yes. I'm gonna ask Mr. Corbett for some. Mr. Corbett seems to have some nice ones as well. Oh my. Normally have some nice examples in but I'm not seeing them. These ones are kind of basic. Give me a sec, guys. Hold on. We're trying to find them. Let's try this one. Yeah, let's try this one without any numbers now. All right, so instruction. Factorize. AB. Don't know why I'm writing so ugly. AB plus AC plus DB. DB, Mr. Pierre, not DP. DB plus DC. No numbers involved with this one. All right, and you're asked to factorize this. Nothing changes. Same rules. You're going to organize your terms into pairs. So you're going to place these two together. And the reason why I can do that, it is simply because I can see two A's repeating themselves. And I can place these two together because over this, I'm seeing two D's repeat themselves. All right. So I know that I have a student in here who is probably saying, then, sir, is it possible that I could put this term and this term together? Oh, most definitely. Most definitely you could do that. And you could put these term and these terms together. Yeah, man, if you want to regroup, you regroup. Here's my problem with regrouping now. you will regroup and mess up the whole problem. So my recommendation is regroup only if it's necessary. If the terms are already grouped by a letter or it's grouped by a common factor, leave the regrouping alone. So in this case, without having to touch anything, I can see that the first two are beside each other because they are common by A's, and the second bracket is common by D's. I don't need to do nothing more. Now in the first bracket, as you can see, A is repeating, and both A's have the same power, so we can just grab out one of the A, no matter which one of the A them. A. What kind of A is that? My lord. Oh dear. My lord. A. All right? Open the bracket. Now, for the first term, if I remove the A from beside the AB, what do you think is left?
B.
Correct. And if I remove the A from beside the AC, what do you think is left?
C.
Very good. Close the bracket. Second bracket. What's repeating itself?
D.
If I remove the D from beside the DB, what do you think is left?
B.
And if I remove the D from beside the DC, what is left?
C.
How do we know that we're doing the right thing? I'm asking you not ask me. So I mean, I do the maths problem, I'm not quite sure, and I'm not
Both the
sure.
brackets are the
How you know
same.
so the brackets are the same? How you know? Sorry. How do you know you're on the right track?
B plus C
Yes,
is in both
brackets
brackets.
are the same.
Correct. Very good. So if you end up with these two brackets being the same, which you should, you're on the right track. If one bracket is different, it means that two things can happen. Is either you regroup and you regroup incorrectly, or you made a mistake with one of the signs. So the rule is, no matter what they on the left, automatically you can just put it down on the right. That's the rule. All right, boom. Now, since the B plus C is common, I can write the B plus C in a bracket by itself. I can run a line through it like that. And then I can obviously see what is left, which is what? A plus what? D. And I close the bracket, yeah? That is it. As I'm going to have you try one, right? Because I think it's only fair. You try one. Give yourself a chance. Try this one. Same instruction. 6AB. Right? Remember, you guys give me permission to go up till 6:45, you know?
8:45.
Sorry, 8:45. I will lose some time there. Teach myself how to do something when I already know how to do. Nonsense. Hi. Chai. 6AB plus 12BC minus 8AC minus 9B squared. All right, let us see how you handle this one. I'm testing you know. You know my stay already, you know. You know, so now get it easy. So go ahead and tell me. I don't know if anybody wants to volunteer to share their thoughts. So I'm going to give you 2 minutes to figure it out. 2 minutes. All right, proceed. Go ahead and shoot your shot.
Yeah, I'm
coming.
Yeah.
I'm coming. Yeah, it'll go on with it. All right, there you go. In fact, I'm giving you 3 minutes. All right. So, did you buck up on a problem?
Yes, sir.
Of course, you're going to buck up on a problem. Because this particular question, if you notice that in the first two, you could easily throw a bracket around it because there's a B and a B here. And also 6. Also, 6 can go into itself and 6 can go into 12. But when you go over yes or no, and you try the way you do, you realize that there is nothing over there that's common.
Yeah.
Good. So with a situation like this now is where it requires you to regroup. I gave you this question just to bring out this point, right? So when you end up with a question like this where you put the first two brackets around you put a pair of bracket around the first two, but when you try to do it for the second two, for the last two, you realize that if you do that, you're gonna end up with terms that are not alike. So now you need to regroup. So I'm gonna keep, since these are already together, I'm gonna keep them there. I'm not gonna try to change anything with this one. However, I'm gonna put the minus. Hold on. No, sir, that incorrect, Mr. Peart. That is very, very incorrect. Okay, so the devil start playing advocate now. All right, give me a minute, guys. Yeah, man. And let's delete the whole entire question. Yep. No worries. By the way, does anybody want to shoot their shot? I'm start pick up one little coward energy. Anybody in your
So
number?
before we go, there's a question I want you to work for me as well, please.
So like you have internet problem, you go in and out. Pardon me? Say that again.
There's a question I'd like you to work for me, please, before we go.
After this, no, of course. One factorization, right?
Yes, sir. Yes.
Okay, all right. All right. So anybody wants to try or should I go ahead and just run through this one? All right. So like no one run through it. So 6AB. All right. So when we can put with this now, we can put the 8AC, not true? Because
Sir,
this
me
will
using
be a
9B
much with that
squared.
one.
So
Oh, you put the 9B square?
3B. So I use 6AB and 9B square
Oh,
minus
so you do it.
9B
All right, no
square.
problem. So 6AB you use it with what? Minus 9B
Minus 9B
squared.
square.
Okay. And then what you do after that now? You put the 12BC or so?
Yes, sir.
Yes, sir.
That's it.
So you put the 12BC right or so. Give me a second. 12BC, you say?
No, I use 8AC plus 12BC.
Oh, you put the 8AC first.
Yes, sir.
So minus 8AC
plus 12BC.
plus 12BC. All right. Can we see what happened now? Can we see what happened? All right. All right. Come on. That no, because we have another question to work.
Sir, you there?
Sir, gone again. Sir, please don't teach yourself. Seems like we lost him again.
The devil strike.
He's gone.
Are you guys still here?
Yes, we're waiting on you to return.
Oh, yeah. Sorry, I got kicked out. Are you guys seeing my screen?
Yes, sir.
Okay. Yeah.
Don't give it answer.
We're having one of those nights, guys. We're having one of those nights. But
Yeah,
it's okay. We're gonna get through it.
absolutely.
Mm-mm-mm-mm.
Times 9 plus 3 plus 12 plus 3 plus 8 is 3.
Mm-hmm. Yeah, somebody that's go on with himself. All right, finally. Oh my. It's like it was never going to come up. Oh my.
I'm not seeing his screen, sir.
Not seeing your screen,
It's
sir.
gone. It's gone. It's gone. Okay, all right. Seen it now, right?
Yes, sir.
Seen it now?
Yes, sir.
Yes, sir.
All right, let's wrap this up quick and fast now. So, son and son do, right? Boom, boom, boom.
Yes, sir.
All right, so what's common for the first two terms?
3. I use
You
3.
have to tell me two of them, you know. You have to tell me the two of them. 3 alone?
I can use 3. Yes, 3.
B.
3 and 4.
3 and B. 3B.
3B.
Right, 3B. Yeah, 4 over the other side. So 3 into 6 goes what? 2 times,
2
right?
times. I bring back
Leave us
the
with
A.
the A. All right.
Minus 3B.
And then now
And
you
then
have minus 3B.
9.
Bracket.
Next bracket now. What's common over there?
4C.
4.
Out of
4C.
then bracket 3B.
And
Open bracket 3B. 3B.
Yeah.
Uh-huh.
Minus 2A.
Minus 2A. So we're in a problem again. You see that? Because the two brackets them turn back way. Yeah, the two brackets them turn back way.
No.
No, sir. Are you right back way?
Am I right back way?
Yes, sir.
Hello. So it is 4. So you say 4.
It's supposed to be 2A and 3B.
Okay, hold on. My device, I don't know why my device is freezing so much. It's insane. It's a brand new iPad, you know? I don't know how it freeze so. All right, so you guys, so what did you get for your final answer?
So that's why.
To get the final answer is 2A minus 3B and 3B minus 4C.
Okay, all right. That's all right. All right, my student that said that they had something for me to work out. Do you want? Can we work this out next class?
Okay, sir.
Yeah, man. So when we start next class, regardless of which topic we teach, I'll attack it for you. Okay.
Okay, sir.
All right, guys. Well, we've passed our time, guys. Have yourself a good night. Be blessed. See you guys on Wednesday.
Okay, bye.
Good night, everyone.
Good night, sir.
Good night.
It's not